Now you have the situation written within the document, but and I've written this pretty small. I'm not sure it's going to be legible, but if you have a decent sized screen, it might well be. We know that my 75 kilogram mass and the Earth's 6.10 to the 24th kilogram mass separated center to center by 6,400 kilometers exerts a force, or results in a mutually attractive force of 750 newtons. That's me attracted to the Earth attracted to me, mutually attracted by a 750 Newton force. The question is now, what if we have two 3 kilogram masses separated by 10 centimeters? How much force would that be? We solve the problem by just considering the fact that, well, if 75 kilograms is shrunk down to 3 kilograms, well, that's going to shrink the force down to 1/25th as much. Just like doubling one of the masses will result in twice as much force, reducing one mass by a factor of 25 would reduce the force by a factor of 25. So, if we just reduced replace me with a 3 kilogram mass, probably be pretty easy to do, replace me with a 3 kilogram mass, we're going to get 1/25th of this force, which would be, what, 30 newtons. Okay? Now, if we also replace the 6 times 10 to the 24th kilograms of the Earth by another 3 kilogram mass, well, we're going to get a factor of 6 times 10 to the 24th over 3. That's 2 times 10 to the 24th. The force will decrease by an additional factor of 2 times 10 to the 24th. And if we shrink our 6,400 kilometers to 10 centimeters, what's going to happen? Well, 6,400 kilometers is 6,400,000 meters, or 6.4 times 10 to the 6th meters. And that's how many centimeters? Well, 100 times that. It's going to be 6.4 times 10 to the 8th centimeters. We take that ratio, 6.4 times 10 to the 8th centimeters over 10 centimeters. That's going to be the ratio of radii. And the force is, since we're shrinking the distance, the force is going to increase by the square of this factor. Okay? So that's going to give us a factor of 4 times 10 to the 15th. So what we have is force increasing or decreasing by a factor of 25 due to shrinking my 75 kilograms down to 3 kilograms, by another factor of 2 times 10 to the 24th by virtue of reducing the mass of the Earth down to 3 kilograms. But it's also going to increase by a factor of 4 times 10 to the 15th. What's the net result of all of that? Well, the force is then going to change by what factor? It's going to increase by a factor of 4 times 10 to the 15th by virtue of bringing things closer together. But then it's going to decrease by a factor of 25 and also by a factor of 2 times 10 to the 24th by virtue of changing my mass and that of the Earth, and we're going to get a net factor of 8 times 10 to the negative 11th. We multiply our 750 newtons by 8 times 10 to the negative 11th, and we get 6 times 10 to the negative 8th newtons. That would be the force between those two 3 kilogram masses. Now we're thinking two spheres, okay, at a separation of 10 centimeters, two 3 kilogram spheres with their centers separated by 10 centimeters. Now that's a really small force. It would be difficult to measure that in a lab, but it isn't difficult to get two 3 kilogram masses, spherical masses, so their centers are separated by 10 centimeters. And there are experiments we can do to actually measure that sort of force.